All right, so we're moving on to section 5 of chapter 6, and in this video we're going to solve what's called a radical equation. Now, a radical equation is an equation that has a variable in a radicand or a variable with a rational exponent. Right? So it's important that you know that the variable is in the radicand or the variable has a rational exponent. Right? We're going to do a few different ways. I'm going to show you two different problems, one where it is in a radicand and one where it's in a rational exponent, or I'm sorry, one where it's in a radicand and one where it has a rational exponent. And then we are going to solve them. All right, so in this lesson, we're going to assume all radicals and expressions with rational exponents represent real numbers. So we won't have any imaginary solutions. All right, so our first example. So here we have, what is the solution of 3 plus the square root of 2x minus 3 is equal to 8? So we know that this is a radical equation because our variable is inside the radical, or it's part of our radicand. It is the radicand. All right, so when we solve a radical equation, you must isolate it, meaning anything that's being multiplied, divide it, add it, subtract it, you need to move it all to the other side, use the inverse operations, and isolate that radical equation. So in this case, the only thing that's being done to it is the plus 3. So we need to get rid of that positive 3, so we will subtract 3 from each side. All right? And then we're left with the square root of 2x minus 3 is equal to 8 minus 3, which is 5. All right, now, we need to get rid of this radical expression. So we need to do the inverse operation of the square root. So since what you do is you identify your index. All right, in this problem there's no powers, nothing's being raised to a power, so you just identify your index. Now if this is being raised to a power, there's something else that you would have to do. You need to rewrite it as a base with a rational exponent. But since there's no powers, all we do is we identify our index, which in this case it's 2, and then we raise that to that power, because that will get rid, the power and the index match, so we'll get rid of our radical and we're left with 2x minus 3. Now, just like any other equation, what you do to one side, you have to do to the other. So then we square that 5. So this is equal to 5 squared, or 25. And now we just have a regular equation that we will add 3 to both sides, so 2x is equal to 28. Divide each side by 2. X is then equal to 14. All right, now what I want you guys to get in the habit of doing, and you'll see in the future, it's important that you do, and if you don't, there's a chance that you can make a mistake, is we are going to take this answer and we're going to substitute it back into our equation just to make sure it works. So 3 plus the square root of 2 times 14 minus 3 is equal to 8. Well, 2 times 14 is equal to 28, so 3 plus the square root of 28 minus 3 is equal to 8. So we're going to do this in one step. 28 minus 3 is 25. The square root of 25 is 5. So 3 plus 5, does this equal to 8? You should be asking yourself that question every time. 8 does equal to 8. Check. It is true. All right, so then we know that that works. So for these radical solutions, radical equations, since you need to check your answers, all right, and then it's going to come back into play in a little bit as to why. All right, we have one more example, and then there's one that you guys will do. All right, so here's the second equation. It's still a radical equation because our variable is still being raised to a rational exponent. So it's still radical. So we still do everything that we would have done before. So we need to isolate this. So we have 3 times x plus 1 to the 2/3 power is equal to 12. Right? So we need to isolate this. So what's being done is this 3 is being multiplied to a radical. So we need to divide each side by 3 to get rid of that 3 and isolate our radical. So x plus 1, or a rational exponent, is raised to the 2/3 power is equal to 4. All right, now, when it's written as a rational exponent, what we need to do is we need to raise this to a power. Right? And what you need to do is you will raise it to the inverse, or I'm sorry, you'll raise it to the reciprocal of your power. So right now our power is 2/3. So remember, you say you love me, but now you flip them like reciprocals. So this reciprocal is 3/2. So then you will raise this to the 3/2 power. And what you do to one side, you have to do to the other. So in this case, the 2 will cancel out to 2, because remember, power to a power we multiply, and the 3 will cancel out to 3, and we're just left with now x plus 1. And now we have 4 to the 3/2 power. So if you are unsure about what this is equal to, rewrite it as a radical. Right? So remember, it's power over index. So this is 4 is being raised to the 3rd power. And I'm going to show you that you can do it either way. So you can do the square root of 4 first. The square root of 4 is 2. And now you're left with 2 cubed, and it's equal to 8. So you can do your square root first if you want, or you could square what's on the inside, or cube what's on the inside first. So 4 cubed is 64. So the square root of 64 is equal to 8. So it does not matter which way you do it because you'll get the same answer. Typically, it's better, especially if you're doing it in your head, to do the radical first because then you're working with the smallest number possible. But now we know that x plus 1 is equal to 8. Then we'll subtract over 1. And then we get x is equal to 7. And remember, we want to check our answers. So we'll plug it back in. So we'll ask ourselves, does 3 times 7 plus 1 raised to the 2/3 power equal to 12? So 7 plus 1 is 8. So 3 times 8 to the 2/3 power, does this equal to 12? So 8 to the 2/3 power, it's power over index, so it's 8 squared, so it's the cubed root of 8 squared. So we'll do the cubed root first, so that's the cubed root of 8 is 2. 2 squared is 4. All right, so sorry, it's a little sloppy now, but we have 3 times 4. Does this equal to 12? And yes, it does, so we know it works. All right, so remember, in the future, you're going to see that you definitely need to start checking your answers. All right, now this is the last example I'm going to go through with you guys, but now going forward, whenever we do this flipped classroom, along with checking your notes, so I can check your notes at any time, there will be questions that you might need to hand in for me. And what you are each going to do now is you're each going to create a document on Google Drive and you will share it with me. So you will all share a document with me. All right, then what you will do is you will solve this answer on your own. And on that, or you will solve this answer on your own. And then after you get that answer, you will take a picture. And on this shared document, you will always, because this is the only document you're going to share with me all year, and you're going to put all your answers onto this same shared document. So you will label each answer. So you will, this is section 6.5, and it's the first video. So you will do 6.5.1, and then you will do colon, and then you will send me your picture. Right? And then if there's another video for 6.5.2, you will do that, and then you'll send me your picture there. All right, so this way I can follow along with your work, and I can see what mistakes, if anyone's making, if there's any common mistake, or I can just see how each of you are doing a little bit better than me walking through your notes through class. All right, so this is something that we're going to do going forward. It may not be in every video. It might be in some of them, but whenever it is, this is how I want you guys to do it. So on this shared document that you will all constantly, you'll use the same shared document over and over again, and you will just title each one that you're doing. All right, so 6.5.1, you'll send me the picture. 6.5.2, you'll send me the picture. All right, it's just easier if you send me a picture because with algebra, there's a lot of steps that I need to see, so you'll probably need to write it out and then share the picture with me. All right, so just upload it onto that document. All right, that's it for this video.